Okay, here's a quick video of the little setup that I've got here to make deuterium deleted water. So first of all, we have an AquaCure set up with the backfire arrestor on the front, which is filled 80% full of water with a special bubbler on the bottom so that it works properly as a backfire arrestor. We happen to have reset the spring inside here for a 7 psi mechanical pressure release, so that if there's any excess pressure, it'll get relieved there. The instead of the tower cap and regular assembly that we have on top, we don't need those, so we've just put the shipping cap back on the top of the water fill stem. Got our levels up there and everything. So that's the AquaCure setup. This hose here then goes to the bottom of this desiccant container, which you can buy on eBay or Amazon. And then the hose on the top comes and goes to the torch. The torch is set in a stopper in such a way that the torch tip won't get water dripped on it. It comes right through there so that the, and I recessed the hole just a little bit so that the driplets of water don't get on the torch tip and block the flow. One of the reasons that we have the desiccant container here is because the gas is wet, and so the desiccant gradually absorbs that, so that it's dry gas going in here. One of the big problems is if there's a little tiny water droplet that's larger than the orifice of the torch tip happens to get in there, then it'll put the flame out because the water droplet won't allow the gas to flow and the flame will go boop and be gone. So anyway, the flame shows down into the flask here, and this particular flask is kind of triangular shaped and has an orifice coming out the side. If you don't have a vent coming out, then the pressure of the steam, because the exhaust of the Brown's gas flame is steam, and the pressure of the steam will build up and stop the flame, because the flame has to have a unrestricted flow coming out in order to keep the flame going. So if you don't have a beaker with a vent, you could use a stopper that has 2 holes in it. They make those, and you could just use one of those as a vent, and that's fine. This flask is triangular shaped because I find that it'll have more water capability. And down in there right now, we've got about probably more than a cup of water that's the deuterium deleted water. In this outside jug is just water bathing to cool the flask so that it enhances the condensation. So we want the steam to lose its heat and turn back into water, liquid water, without being vented out the side there. So that's and then when you go to start the torch, you just open it up until the green light here is just barely flashing. So what we'll do here is we'll start the machine. And in this case, I hold this button here for 10 seconds until the machine starts. And that bypasses the timer, so now it'll just run continuous. And you saw the green light go out almost immediately because it built up pressure. There's no place for the gas to go, so the pressure switch inside shut it off. Pressure switch in the AquaCure is set for about 2 psi. And just holds it there. Now, when we go to start the torch, we open this up, and as we open, I'm going to continue to open, you'll see the light come on as the pressure drops, and it's flashing like that because every time the pressure builds up to 2 psi, it shuts off, and then as the gas is relieved, then the pressure drops and it turns back on again. So as long as that green light is flashing, you know that you're making more gas, or sorry, you're using less gas than the machine is making, than the AquaCure is making. So the flame will be steady. So I'm opening up the torch even more until it just barely flashes once in a while. As long as it's flashing at all, you know that you're still not using as much gas as the machine is making. Okay, I could probably use a slightly larger, torch is wide open now, and the orifice of the torch is holding the thing in place. So since I don't have a stand here, I'm going to have to set the camera down for a minute while I'll get a little stand thing happening here, while I light the torch. And I'm just using a regular lighter to light the torch. The gas is flowing, so I just put a flame up there and the torch is lit. Yeah. Now it's very difficult to see a Brown's gas flame. Let's bring it up here again. Now this one has got a tiny little bit of lye on the torch tip, so it colored the flame yellow. Let's see if we can. Okay, against the black background there you can see. Now, what's the visible part of the flame is about an inch or an inch and a half, and that is, the flame is about 3 or 4 times longer than that. So one of the things you really must do is make sure to have a very deep flask, because if that flame touches the bottom of whatever flask you're using, it'll burn right through it. So then what we do is we put the torch in there, and now the flame is directed down into there, and as the flame burns, the steam, the resulting steam will be condensed and fall into the bottom. So that's pretty much the setup as it is set up. Now, if the torch goes out for some reason, little water droplet or something like that, remember there's hydrogen in here, because then with no torch, no flame going, it's just ejecting Brown's gas directly into there. So if you go to relight the torch, or the orifice there, and then go to put the flame down in here, you're going to ignite that gas and it'll cause a little woof to come up out of there. So just don't be startled if that happens. It's not dangerous or anything. It's just because it's all low pressure combustion. But don't get startled. Okay. So that gives you a bit of an idea of the experimental apparatus that we have going in order to make the deuterium deleted water. And I call it deleted water because so far every test that's been done of it, it's not deuterium depleted, because there really doesn't seem to be any deuterium in it at all. So it's like zero deuterium. Certainly far less than 5 parts per million, which is the standard that they test against. So I'm calling this DDW from the AquaCure and Brown's gas flame deuterium deleted water instead of deuterium depleted water. Enjoy.